Hello again. Here we go with some notes on how to determine bond type. Now, a lot of you are probably going to recognize this from the homework page that we had. We're basically just taking the difference in electronegativity to determine the different ionic or covalent character going on within the bonds. So bonding between atoms of different elements falls somewhere in between ionic and covalent bonding. The electronegativity is the measure of an atom's ability to attract those electrons. So remembering the trend, in general, metals will have a low electronegativity. The reason this is because metals want to lose an electron. They don't actually want to gain any electrons, so their affinity for them is very low. Okay, for nonmetals, they'll have a very high electronegativity because they actually want to gain their electrons, right? That's why they have those the negative charges. So comparatively, electronegativity decreases going down a group, and electronegativity increases across the period from left to right. So then calculating the difference in electronegativity can tell us the degree to which bonding is ionic or covalent. And we talk about it in terms of ionic character, meaning how much are they taking those electrons more towards one atom over the other. Within covalent bonding, there are two types. There's polar and nonpolar. If you have two atoms of the exact same element, this is going to be completely covalent, meaning 100% nonpolar. They're sharing 100% equally. And that's what a nonpolar covalent bond is. It's a covalent bond in which bonding electrons are shared equally. That's the key word there. Additionally, in a nonpolar covalent bond, there would be balanced distribution of the electrical charge. Whereas in polar covalent, there is an unequal attraction for the shared electrons. So when I look at the figure here, notice that in a pure nonpolar covalent bond, the electron clouds look to be shared very equally. However, in a polar covalent bond, notice that the atom on the left has more of the electron cloud going towards it. That's because its electronegativity is much greater than the one on the right. So that's an unequal sharing of the electron cloud. And then last but not least, in our ionic bonding, they're not even shared at all. In fact, this is what we would call a transfer of electrons. Okay, so then within the ranges, remember that all the way up to 0.4 difference is going to be nonpolar. Anything in this diagram has it up to 2.0, which is fine. That would be considered polar covalent, and anything greater than 2.0 is definitely ionic. Okay, so just a few little example problems here. Identify the type of bond for the following. If I take H, find it on the periodic table, find Cl, that one's a 3.0, and I subtract those two numbers, I get 0.9, which is polar covalent. For number 2, same thing, find hydrogen, 2.1, oxygen is 3.5. When I subtract those, we get a difference of 1.4. That lands in the polar range as well. And then for CH4, that's methane, that's the name of CH4, 2.5 minus 2.1 lands us in the nonpolar region. And then last but not least, for lithium, right? Lithium's over here. And then 4.0 for fluorine, our most electronegative element. That lands us right in the ionic range. Okay, so that's how to determine bond types using electronegativity.